Okay, it's time to take a look at an equation that is one of the more commonly, not misunderstood, but more difficult to recognize equations than a lot of the rest. It's not because the math is difficult or the math is more challenging than normal. It's because of where the variable lies that makes this kind of a challenge to undo, essentially. And if you notice this, just look at some basics. That x happens to be an exponent. And the whole reason we've been dealing with logarithms is so that we could represent unknown exponents. So when you see this kind of a scenario where the variable is an exponent, you need to be thinking to yourself, logarithms. Okay? Logarithms is how I'm going to have to do this. At some point, a logarithm is going to come into play. So let's take a look at where that might be. And I'll erase some of these things up here, and we'll jump into the problem. Now, you have quite a few skills already. Okay, this is not something that you are totally unfamiliar with. We see that this part right here looks like the challenging part, so let's get rid of that 5. We're going to move that 5 over to the other side. And what we get is 2 to the 3x power equals 8. Now notice I'm writing it with some space here, and I'm doing that intentionally. Now, a lot of people at this point want to take and try and divide that 2 over to the other side, but that doesn't make any sense. Okay, I'm saying 2 to this unknown power equals 8. Now this happens to be a problem you could do mentally. We'll get to that in a minute. Right now I just want to show you the formal process for one that you couldn't do in your head. So if I'm trying to get rid of a base, and when I say base I mean this number, I'm going to try to move that number to the other side. The way to basically undo that, and this is a bad way of saying it, but I'm going to use a logarithm to make that go away. And what I'm really doing is I'm using a logarithm to try to get at this value right here. What I'm going to do, I have a base of 2, so I'm going to use a logarithm with a base of 2. But if I do that to one side, I have to do it to the other side. Oops. And notice that's why I left a little bit of room there. Now log base 2 of 2 to the 3x is basically saying 2, that number right there, to the what power equals 2 to the 3x. And the short answer to that is 3x. That's my exponent. Now if you go back to the meaning of logarithms, you can kind of rewrite these out the way you would mentally think about them, and you'll be able to see that that's true. For short purposes, a log base 2 of 2, basically that cancels out. So I'm left with 3x on this side. Now over here, I have a logarithm that I can do in my head. Now it's not always that way. Sometimes you get a number here that you're going to need to use a calculator for, and later on we'll get into the change of base formula, which allows us to do that. Okay. But in this case, log base 2 of 8 really means 2 to the what power equals 8. And we know that 2 to the third equals 8. So this entire logarithm right here represents a number of 3. And now I have this easy equation, 3x equals 3. I divide 3 out of there and I get x equals 1. Now that's something I probably could have done right from the beginning. I mean, if I am just thinking about this problem, I'm going to go, oh, you know what? If this right here was a 1, then this would be 2 cubed minus 5 equals 3. And most of you would know that 8 minus 5 is 3. So that might be something you can just look at and see the answer to, but oftentimes this value is not going to be a whole number. And so we would use this process, especially on something that it's not a whole number, and there's no way we could actually do it in our head. Okay, no person in their right mind would know some of these answers that turn out to be decimals. So that's what we're going to do, is we're going to set it up, and if you need to get rid of a base, if you need this base to basically move to the other side, you're going to have to take a logarithm of both sides to make that happen. Okay, if we're ever trying to find an unknown exponent, at some point we're going to have to use a logarithm. And the logarithm is always going to have the base on it that is attached to that exponent.